Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are doing question 14 of chapter 7F, so your partial fraction chapter. If you haven't checked out the topic video for partial fractions yet, make sure you do that. I'll leave it in the link below or up on the pop-up above. But aside from that guys, let's get into the question because that's what you're here for. Question 14. Let fx equals to x squared plus 6x plus 5 divided by two factors we have here, x minus 2 and x squared plus x plus 1. So this is a clear case of partial fraction, and that's because you have two factors on your denominator. Also, what kind of partial fraction is this? So there are three types of partial fractions. You can get either 1, the linear, 2, the repeated linear factors, or 3, the irreducible one, right? So we have to make sure that we apply the correct partial fraction. And the one that we should apply here is the third one. Why is that the case? That's because if you look at the second factor, that is an irreducible factor. X squared plus x plus 1, if you were to find the discriminant, b squared minus 4ac, b squared in this case is 1, minus 4 times 1, a is 1, c is also 1. So 1 minus 4 is minus 3. If you have a negative discriminant, that means you cannot turn this into linear factors. That's it. You can't reduce it. You can't really factorize it anymore. So in that case, irreducible factor, that's what we have, okay? So number 3, that's how we should apply the partial fraction. So let's get into answering the question. Part A, express fx as partial fraction. So technically, that's pretty much what we're going to do anyway, regardless. Cool. So how would you apply the irreducible partial fraction? If you want to do this, apply the formula. It's a over the linear factor, which is x minus 2, plus bx plus c over the irreducible quadratic factor, which is x squared plus x plus 1. Now the goal is to solve for a, solve for b, and solve for c. How would we do that? Well, we equate the coefficients. So we make the denominator the same. So on the denominator, you want x minus 2, you want them to have the common denominator, x minus 2, x squared plus x plus 1, and then it will be the same as the one on the left hand side, right? So x minus 2, x squared plus x plus 1, that is the same, but now the top, we're going to change things on the right hand side. So a times by, what am I missing? So a, the denominator already had an x minus 2, what am I missing? The x squared plus x plus 1. If you want to have this fraction as the same denominator as this, you multiply a, or you multiply this fraction by x squared plus x plus 1, both on the numerator and both on the denominator. So we get a times x squared, whoops, without the square here, plus x plus 1. And then of course the bx plus c, what are we missing? We multiply by the x minus 2. Right, so if you do that guys, I'm just going to take out the denominator because they're the same. You can just cancel them out, okay? So not required anymore. Okay, let's expand. Ax squared plus ax plus a plus bx squared. So bx times x is bx squared. Bx times negative 2b, negative 2 is negative 2bx. And then of course we expand the c as well. That is cx minus 2c. And of course that is equals to x squared plus 6x plus 5. Right, I am equating coefficients now. So that means this part right here, ax squared plus bx squared must equals to 1x squared. So instead of writing this bunch of equations, you can write it as a plus b. So we're just equating coefficients. A plus b equals to 1. That is our equation number 1. And then keep looking. We have ax minus 2bx plus cx. So all of them have x as your variable. And then over here, the one that has x as the variable is the number 6. So you equate the coefficient once again. So we take a plus b. A minus 2b, right here, a minus 2b, and then plus c, and that is equals to 6, equation number 2. And the last coefficient that we're going to equate, this one right here, a and minus 2c, that is equals to 5. So a minus 2c equals to 5, that is equation number 3. And of course, we have to do simultaneous to solve for a, b, and c. There are 3 equations, there are also 3 variables. So if there are 3 equations and 3 variables, or the same number of variables as the equations, you can definitely do simultaneous, okay? So we can definitely do it right here. How would you approach this? If you look at the first, second, and third equation, they all have a in common, right? So why not make a the independent variable. So what I mean by this is equation number 1, you can write it as b equals to 1 minus a, and equation number 3, you can write it as c equals to, so I'm going to move the c over, move the 5 over, that's a minus 5, everything divided by 2c. Okay, so now that you have b in terms of a, you have c in terms of a. If you chuck both of these equations inside number 2, equation number 2, then you have the one equation with only one variable, which is the a variable. So that's how you should approach this, guys. Equation number 2, I'm just going to write it down over here. That is a minus 2 multiplied by b, which is 1 minus a. And then, of course, plus c, right? What is plus c? C is a minus 5. Oh, and this is 2, my apologies, just 2 by itself. So in that case, divided by 2. And then, of course, equals to 6, equation number 2, right? I'm just rewriting equation number 2 in terms of a. So let's expand the bracket, bring all this 2 up here. Let's do that quickly. A minus 2. Minus 2 times 1 is minus 2. Minus 2 times minus a is plus 2a. And of course, plus a minus 5. Everything divided by 2 equals to 6. Now I'm going to bring the 2 upwards to all terms. So 2 times a is 2a. Minus 2 times 2 is 4. Plus 2a times 2 is 4a. And then plus a minus 5, I'm going to bring the 2 over here as well, 12, and we can just get rid of the denominator for 2. Now let's add up all the a's. 2a plus 4a plus 6 plus a is 7a. And then minus 4 minus 5 is minus 9 equals to 12. And then 7a is equals to 21. Therefore, a is equals to 3. So that's pretty convenient. You do get a good number. And usually that's the case for Tech 3 or if you're doing things by hand. The question will always give you something nice, like the numbers will be quite nice, or else it's going to be really painful to actually do the question. Of course, a equals to 3, and we know from equation number 1 here, b is 1 minus a, so b is 1 minus 3, which is minus 2. And let's solve for c. C is a minus 5 divided by 2. A we know is 3 minus 5, and then divided by 2. So in that case, c equals to negative 1, okay? Negative 2 divided by 2, negative 1. Once you found your a, b, and c, we have to chalk it back over here. So I'm going to write it on the right-hand side quickly. So x squared plus 6x plus 5 divided by this is the same as writing a, which we know is 3, divided by x minus 2, and then plus bx plus c. Now, b and c are negative 2 and negative 1 respectively. In that case, it's negative 2x minus 1 over the irreducible factor, which is x squared plus x plus 1. If you wanted to write this neatly, you can get rid of the negative over here. So that's minus 2x plus 1 divided by x squared plus x plus 1. That negative applies to both terms up here. Okay, so that's part A, guys, which is pretty much express fx as a partial fraction. So this is our partial fraction. So this is another way of writing fx pretty much, okay? Part A, all done. Let's look into part B, which is hence find an antiderivative of fx. So the reason why we did partial fraction first is if you were to antiderive this function right here, just straight out, you cannot do it. You have to turn into partial fractions first, so turn into this form, and then you can antidiff. And I'll show you guys how to do that over here.